So last class, we talked a lot about taking the derivative of e to the stuff, and we found that the derivative of e to the stuff was e to the stuff d stuff. Well, honestly, guys, it's not that hard to reverse, because if its derivative is e to the x, then its integral might as well be e to the u, if we're talking about in terms of u, plus c. So we've got a new rule. Let's shake it up and do a couple of examples. So I've got e to the stuff. We want to take the antiderivative. So let's set up a u substitution where we say u is equal to 3x plus 1, which makes du 3 dx. I don't have a 3, so 1/3 du is equal to dx. So I'm going to rewrite this thing as the integral 1/3 e to the u du, which is a pretty easy antiderivative to take, because if its derivative is e to the x, its integral is e to the x. So e to the u plus c's final step, we're going to throw in our original u of 3x plus 1. Don't forget your plus c. Short and sweet, okay? So what I'd like for you to try is press pause on the video, try the second example, which again is another u substitution. So my hope is that you're joining us and you've already tried this example. I think the 5 can kind of throw you off. One of the things that I would tell you is to maybe take that 5 and toss it to the outside so that you're not even kind of considering it as part of this before you get going. So you go to set up a u substitution, you let u be negative x squared because it's the inside function within a function, which means that du is going to be negative 2x dx. I forgot my dx. I'm going to divide out my negative 1/2 and just get x dx. So I still have my 5 chilling out front. I've got a negative 1/2 that we're not going to add to this party. Integral, my x gets taken care of by the du, so I basically end up with e to the u du. For a final answer of negative, well, almost final answer, negative 5/2 e to the u plus c. It's an indefinite integral, so don't forget your plus c. Last and final step, toss in your e to the negative x squared. And don't forget your plus c. So hopefully you did okay on that one. I do want to do a little bit trickier example with you, because I think this next one is not at all as obvious as maybe the previous ones before it. So in this next example, I think that x squared on the bottom can be really, really deceiving. But remember, the goal here is to kind of discover what's your u and what's your du. So it might be worthwhile for you to kind of see this as 1 over x squared times e to the 1 over x dx, because then I think it becomes a little more obvious that u is going to be 1 over x. And you might want to think about that as x to the negative 1, which means that du is negative x to the negative 2 dx. Which is the same thing as what we have going on right here, except for the negative. So we're going to divide out the negative. And we're now able to take care of all of the pieces. So we rewrite this as negative integral. This and this get taken care of by my du. And so all I have is e to the u du. And what looked really ugly folds up to be a really nice function, because e to the u plus c kind of folds up pretty naturally. And we're going to say negative e to the 1 over x and substitute back in our u plus c for our final answer. So again, I'm going to ask you to press pause and give the one at the bottom of the page. I don't think this one's very bad at all, because I think it's relatively easy to see that we want to turn the cosine x into our u, which is going to make our du negative sine x dx. I don't have a negative, so if we multiply both sides by a negative, that's going to make that positive. And I can rewrite this as negative integral e to the u du. And honestly, all of these have rewritten super, super nice. So negative e to the u plus c to give us a final answer of negative e to the cosine x plus c. And this goes without saying. I think it's good to remember that you can always check your work by taking the derivative and going backwards. It's not a bad idea. So what I want to do is mix up a couple rules. We're not going to do the entire next page, but maybe 2 or 3 of these just kind of give us a head start on this next lesson. So for this next one, I think it's an interesting question because you're trying to figure out, okay, what's my u, what's going on here? You can't split up the fraction. So remember, the worst thing that could possibly happen, guys, is that you try something and it doesn't work. So try it. Remember, when you're identifying u, you're never going to have a dub on the bottom. So if you're looking at a fraction, your first guess at what should be a u is probably going to be the denominator. So e to the x plus 5, let's just try it and see what happens. If we do that, then du, the derivative of e to the x, is just e to the x dx. And then I can see that e to the x dx right there. So what looked like a really nasty integral becomes straight up 1 over u du. Now let's see if you remember your rules from last time. If I have the antiderivative of 1 over u, that's natural log absolute value of u plus c. So my final answer is natural log absolute value e to the x plus 5 plus c. And it's not so bad. All right. But we get to this next one, and I kind of throw the hammer just a little bit. Okay. We get to this next one and we start to try u sub. So let's say we did try u sub, and remember, we would want our u to potentially be the thing on the bottom. So I go, okay, let's let u be e to the 3x. Don't write this. Well then, what would du be? It would be e to the 3x times 3 dx. And then I look at my numerator and go, oh my gosh, yuck, that's not what I have. So this is not going to work. Okay? But we can do something smart here. Anytime you have stuff in the numerator separated by addition, why not split it up into 2 parts? Okay, so let's say I do split this up. Now we've got to kind of remember our properties of exponents. I have the same base. Properties of exponents say that I can take these exponents and I can subtract them. So that's going to become e to the 4x dx. And similarly over here, I have x minus 3x, which is going to give us e to the negative 2x dx. And I'm going to take both of these and we're going to throw a real quick u sub on them. So u is 4x. du becomes 4 dx. I don't have a 4, so 1/4 du is equal to dx. So I can take my first one and completely rewrite it as 1/4 integral e to the u du. And I'm going to do the same thing with the other one, except I can't use u if I've already established that as a variable. Let's use v. Let's make it negative 2x. So dv will be negative 2 dx. I don't have a negative 2, so let's get rid of it. Negative 1/2 dv will be equal to dx. Sorry, guys, my stylus is cutting out on me. So this is going to turn into a minus 1/2 integral of e to the v dv. And I have a pretty easy way of going about doing this from here. So we get 1/4 e to the u minus 1/2 e to the v. You only need 1 plus c in this whole big thing because it's not a definite integral. And then we're going to go and substitute back in what we originally had for a final answer of 1/4 e to the 4x minus 1/2 e to the negative 2x plus c. And again, check your work. You can take this, go check your work, take the derivative, and you should end up right back in the same place. So along those same lines, here's where you guys get to try some and where I'm going to leave you. You guys are going to try this one on your own and this one on your own, and we'll call it a day after that. When we come in for class, I will check those two. Don't just leave them blank. Give them a genuine effort, please. Okay? I promised Reese I'd keep this short and sweet, so here's your 10-minute video. Y'all have a great weekend.